So my name is Leszek. I'm cloud consultant in GDC team. So GDC team stands for Global Delivery Center. So we're actually a team of people that are delivering projects for our customers, but also helping partners to deliver projects on Google Cloud, right? So like migration projects, improving the Google Cloud infrastructure for our customers. And I'll be talking today about the life of network configuration change on Google Cloud. And I will also extend that idea to speak a little bit more about configuration change on Google Cloud. So think about the scenario when you're troubleshooting the problem. And there are numerous of questions that you can ask, right? But what's your number one question that you would ask when troubleshooting the issue? The environment was working, it's not working right now. So what's the number one question that you can think of? And then you can open to share your opinion, your feedback.
It's changed.
And that's a very good question, yeah? So I don't have anything to add because that's my number one question as well, right? So what has changed, yeah, right? It's critical to understand what has changed before working scenario and not working scenario right now. And the reason I started with that, because we're gonna be talking about those changes, right? How to avoid bad configuration changes and how to find those configuration changes in your environment when they happen. So let's think about that bad configuration change in your environment. I've divided the life of the configuration change into 3 stages. So stage 1, the configuration is created and it's causing some issues on your environment. Stage 2, the issue is discovered. And stage 3, the problem is troubleshooted and ideally it's fixed later on and your environment is working just fine. So during today's presentation, we're gonna focus on first 2 phases. So on creating bad configuration, and we're gonna discuss how to avoid it using GitOps methodology, GitOps idea. And then we're also gonna talk about network analyzer and how does it help us to discover those issues. Right? Because as we mentioned, discovering what has changed is that critical concept to fixing the issue. We're not going to cover troubleshooting. Troubleshooting is probably something that we can cover later on some other sessions, maybe future GDG sessions. So the agenda for today is we're going to start talking about network analyzer. That's going to be followed by short demo of network analyzer. Then we're going to do GitOps introduction, followed by short demo. So in total, we're going to have 2 short demos that I think will help you understand those two things. So let's start with network analyzer. So what is network analyzer? Network analyzer is actually the service that is part of network intelligence. And for those of you that are doing networking on Google Cloud, you know that some time ago we implemented that network intelligence component. And it's a free service. It's ready for you to use. It's currently in preview phase. Right, so there might be still some glitches in the solution, but it's enabled for you by default. And what Network Analyzer does, it actually automatically monitors your VPC configuration and detects misconfiguration. So let's say you're gonna make some network configuration change that is affecting your environment. In ideal scenario, Network Analyzer will discover it, notify you, and will kind of guide you to how to resolve that specific issue. So what are the benefits? The benefits are essentially focusing on saving time and money, right? Because if you can find the issue quickly, then you can quickly resolve it. And if you quickly resolve it, then you avoid long outages. So it's saving you a lot of money and effort, right? So in the times before Network Analyzer, customers would have to manually set up connectivity tests. And that, if the connectivity test was not set up before the issue happened, then they would need to set it up after the issue happened, and that's taking time, right? So you have the issue, you set up connectivity test, that helps you find the specific issue, right? And that's, of course, taking a time. And Network Analyzer would automatically surface common config issues. And I want to highlight that common configuration issue, because what our team did with Network Analyzer, our Google Cloud team, is they actually took all the issues that are either cloud blockers for our customers or are generating a lot of issues with our support team, and they kind of try to order them in and build the analyzers for those most impacting and most important issues, right? That's why I have those common config issues, and currently we've got around 10 analyzers that are being checked, but that number is going to grow later on. So how does network analyzer work, right? So let's say you've got bad configuration change that is usually implemented by some type of user, right? I know it can be automated, and we're going to talk about that automation. Then we've got schedulers, and those schedulers are actually running within 10 minutes. Once you do the configuration, that issue should be discovered. 10, maybe maximum 20 minutes, depending when you're going to hit the schedule, because the scheduler is run after 10 minutes from the bad configuration change. Then the change is passed through the analyzer, and the analyzer is spotting the issue. Then you have the notification in that network analyzer panel. And the other direction, if you fix the issue, the analyzer is supposed to detect that fix, and it's gonna make that visible for you in the network analyzer console. And I've picked a couple of examples. Let me just, okay. My slides got a little messed up. So what do we actually check, right? So currently you can see the components, and you can see number of checks that are currently implemented. So currently we've got what, 12 checks that are being implemented in preview phase. But the number I could see in our roadmap, we've got plus 15 checks that are being worked on currently, right? So you can imagine that number in probably a couple months will be around 20, 30 checks that are being run constantly on your environment that can help you to find those issues. And I specifically don't want to talk about each and every of the checks. I just want to give you like high-level idea and talk about two specific ones. So what you can actually expect from network analyzer on a high level. And I'm just gonna go back here. I've picked two checks, right? So one of the checks is for VPC network, and that check is checking for your routing to next hop. There's a simplified topology here. So in our topology, we've got a couple of VPC networks, and those VPC networks are having routing enabled through security network appliance, right? It can be routing network appliance. So as you probably know, in VPC networks, you can have that manual routing configuration. And let's say you set up your routing configuration in the way that you're sending your traffic to our security appliance. And that security appliance is just a compute engine machine. So in the case when your security appliance is deleted, it's stopped, or is removed from an environment, or it's paused, the network analyzer will detect that trigger, and based on that trigger, it will give you the alert in the console, right? So that's the example of one of the checks. The other check is I've picked for a showcase is hybrid connectivity. This is a little bit more complex topology. We've got Google Cloud, that is our cloud environment. And I want you to focus on the subnets, right? So we've got two subnets, 10.10.10.0 and 10.20.20.0. And what we have on top of that, we've got our on-prem environment, which is very common setup, right? And on our on-prem environment, we've got also our subnet 10.20.20.0. And you might say to yourself, okay, why don't you prevent such a configuration to happen, right? In some cases, we do prevent such a configuration. So for example, when you want to configure peering between two VPCs, right? And there's overlap on the subnets, we won't allow you to do that peering, right? But in such a cases, it's not possible to do it because on-prem and Google Cloud communicate through BGP. And BGP is the routing protocol that is dynamically exchanging the routes between on-prem and Google Cloud. And because it's dynamic, and you can keep on adding subnets on-prem, you cannot avoid that before, right? Because On your on-prem, you might just add subnet, and automatically it's going to be advertised to Google Cloud. So we've got that topology. There's overlap between subnets on-prem and Google Cloud, which results in insufficient routing. Because if you're setting up your on-prem with subnet, your expectation would be to route to on-prem in most cases, right? So your VPC subnet has two routes: one to on-prem and one to Google Cloud, and it would select the one to Google Cloud, which is unexpected scenario, and that again will trigger the network analyzer alert or information so that you can work on it, right? And you might say, okay, that's expected, right? I wanted to set up my environment this way, and that's no problem. We're just notifying you that that's inefficient configuration, and you can choose to act on it, meaning changing configuration, or you can just leave it and say, okay, I know about it, that's expected setup. So let's move on to short demo. That's gonna be very quick because network analyzer is fairly simple from user's perspective. Let me just move to my... Okay. So we've got Cloud Console, we've got Network Intelligence Center, Network Analyzer. Okay, here it is, and as I mentioned, I think the size is right, so I will keep it like this one. So you can see on my console that I have those categories. I've got summary on all those categories here. The summary of all the alerts is below, and I've triggered a couple of alerts. One is specifically the one that I explained, manual route to VM, Lexcos, and all the information related to it. You can also see that I have active alerts and I've got filtering enabled. If I disable that filter, you can also see that I've got another alert here that is very similar. It's warning alert that is triggered because of the routing, inefficient routing. And this one is fixed because the machine, at some point, the machine was stopped. Then that next hop VM was stopped. The alert was triggered. Then virtual machine was restored, and the alert was marked as fixed. What's important for us here is the view. So in the view, you might expect that we will give you clear guidelines. Okay, you have to go to this VM and click stop or click start VM. But we don't give you that information. We just give you some kind of details that will kind of guide you to solve the issue. And the reason behind that is that maybe your environment is not manually configured, right? Maybe you're using tools like Terraform to deploy it, right? So we cannot tell you, hey, stop that machine from console, because what might happen, your engineer is gonna go and stop the machine, but then you're gonna run automatic Terraform, and Terraform is gonna start it, right? That's why we don't give that guidance, because that might be a little bit confusing. So with that, I think we can move on to the next part of the presentation, which is gonna be about avoiding bad configuration changes. So, but before that, I will just open for the questions. Does anyone have any questions on that network analyzer part?
I was actually wondering why. I know that the reasoning behind manually making to migration is that train of thought is valid, but I was wondering why don't you give the users the option to have just a big blue button that says fix and does all those things?
Yeah, that's mainly the reason that I've explained, because they might be implementing environment in a different way, right? They might be doing it from console. They may be doing that directly through API, maybe through Terraform that is communicating with API. Maybe the best practice is going to console and run it through the console, right? So there are different ways to fix it. And just giving one fix button might cause more harm than good, right? Because they will click that fix button, but then let's say their daily Terraform check or whatever they might have will be checking the environment if it's the same status as in Terraform file, and it's gonna shut it down or bring it up once again. Yeah, so that's the main reason. Yeah, good question. Thanks. Now let's move on to GitOps introduction. And that essentially is gonna go to that first phase, which is creating the configuration and how to avoid creating bad configuration in your environment. But before we're gonna move, I just wanna please raise your hands if you're using GitOps methodology right now. Okay. Okay, so I'll give a bit of introduction to GitOps so that we're on the same page. Maybe let's start with infrastructure as code. Who's familiar with infrastructure as code here? Okay, we've got many more hands raised. That's good. So infrastructure as a code is essentially the concept that is allowing you to define your infrastructure with code, with a file, right? So instead of going to your cloud console and clicking through, hey, I want to start my virtual machine or my cloud compute machine, right? And it's gonna have those such specific parameters. Instead of doing that, what you do, you define all those things in the file, in the YAML file, and the most popular infrastructure as a code tool is Terraform. So in most cases, that's gonna be Terraform. You define, I wanna have this specific machine, and then you send that information through API to your Google Cloud in our case, and Google Cloud is deploying that machine for you. And that approach is actually helping us it's fixing a lot of things, right? Because let's say you've got 3 different environments, and you can say, okay, 3 different environments is not such a big thing. If I need to deploy virtual machine in 3 different environments, I can go to each and deploy virtual machine, right? But everything has a scale limit, right? So let's say you've got many more environments, right? And infrastructure as a code approach is helping you to scale that approach, right? So you build one code and you deploy it to different virtual machines, so to different environments, and you don't hit a problem that there's gonna be some inconsistency, that someone made a typo because they choose for QA environment different network interface that we wanted, right? But at the same time, infrastructure as code is solving some issues, but it's implementing other issues, right? Because the problem with the code is that, let's say you're a developer, right? Or you're developing infrastructure as a code files. And you store them on your laptop. You don't have any history, any versioning. You don't have any way to work in the groups on that file, right? And you've got many people usually administrating environments. So imagine many people keeping those files on their laptops, trying to push the changes to your environment, right? That's a big problem. That's why some time ago, in 2017 actually, Waveworks created the idea of GitOps. And GitOps is actually the idea where you have a code, so why don't you store it on Git repository? And on Git repository, you have an option to work in the teams, to keep the versioning, to roll back your code of the infrastructure the way you want, right? So you can easily track what happened, keep the history of all the changes, keep the approval process in place in solutions like GitHub, etc. Right? So we're actually taking the best from software developers into infrastructure deployment, right? So that's generally the idea. So let's say we've got Terraform code, we're putting that code on GitHub, and on GitHub, that's very simplified flow, right? But and it's also what's worth mentioning is just an example. There are different ways you could implement infrastructure as code in your or GitOps in your environment using different tools. I've just selected the one that is fairly common, and quite a lot of companies actually use it, right? So you put Terraform file, which is just the Terraform code, and we're gonna show it in the demo. You put it on GitHub, and you branch it, right? You have 2 branches. You've got test branch and a main branch. When you do the code change on test branch, what we're gonna do in our example, we're gonna trigger CloudBuild task. And that CloudBuild task, what it's gonna do, it's gonna do Terraform init, Terraform plan, and Terraform vet. So essentially what is important for you is it's gonna take that code, it's gonna install all relevant components to run, and it's gonna prepare the plan. And preparing the plan is essentially taking all the information about your infrastructure and planning it for your environments, right? So the plan is essentially gonna tell, hey, I've got so many machines to deploy, and on such an environment, so many machines to destroy. And I'm simplifying, I'm saying machines, right? But it can be any component of Google Cloud, essentially. And on top of that, we're gonna enhance our GitOps operation a little, because what we're gonna do, we're also gonna do Terraform Vet. And Terraform Vet is, you might know it as Terraform Validator. What it's gonna do, it's also gonna check your code against specific constraints. So taking our example of virtual machine, you can assign, for example, external IP address to your machine, but maybe your company policy doesn't allow that, right? So during Terraform Vet, Terraform verification part, we can verify if specific security, in most cases security settings, are allowed or not allowed. And if they are allowed, then we're gonna pass it through and we're gonna allow it to be merged into main branch. And in main branch, we can run Terraform deploy using CloudBuild task, and CloudBuild task is gonna deploy their environment in our Google Cloud solution. And with that, we can move on to the demo. But before that, are there any questions about GitOps, GitOps part, that high-level architecture? Why not? I mean, because the CloudBuild is actually having service accounts to deploy the environment, right? So it actually has the access to your environment on Google Cloud to deploy it. That's one of the reasons. I'm not sure if that answers your question. So on GitHub, no, I mean, in this case, we're not storing any service accounts on GitHub or anything, right? We're only storing our Terraform code and a couple of other things, but we're not storing service accounts, right? I think when I'm gonna go through the demo and the question is still not answered, then we can come back to it. That's fine, okay? Because I think some of the things might be clarified during the demo. Okay, so let's go to the demo. I'm just gonna switch to CloudBuild. Okay, so let's take a look of what we have in each place. You remember that we had a couple of components. We had GitHub, we had CloudBuild. So let's maybe start with GitHub, and I think it's visible. So on GitHub we have Terraform file, and it's somewhere here. We've got main Terraform file, and it's very simple. That our Terraform file is basically saying, hey, Google, we want to deploy resource, and the resource is Google Cloud Storage Bucket, and it has a name SB Bucket Leszek 08. And we want to deploy it in location Europe North, right? That's what we have on GitHub. And what we also have, we've got two branches. We've got test branch and master branch. You remember that from that previous slide, we had test branch and master branch, right? We had two branches. And on top of that, we've got on GitHub, what we have CloudBuild definition, but I'm gonna go through those definitions in CloudBuild part. But what we have, we've got policy libraries. So policy libraries are actually used by Terraform Vet. So this is the place that is gonna basically tell us what checks do we need to do. So in our case, we're gonna just use one check, and that check is storage location. So we have one constraint that is saying my organization is allowed to deploy cloud storage in two locations. And I'm actually showing here that we've got allow list, and we're allowing to deploy cloud storage bucket in Asia Southwest and Europe North. That's what we have on Google Cloud, on GitHub part. On Google Cloud, we've got a little more configuration. We've got triggers, and what we're interested in is those two first triggers. I'm gonna go a little deeper into that CI part. So we've got CI, GitOps, and what that trigger does is essentially triggered whenever someone is pushing the change to our branch, and it's linked to our repository, right? So I'm telling my CloudBuild to listen to whatever change is gonna happen in my GitHub repository on branch that is called test branch, right? So whenever something happens on that branch, we trigger CloudBuild, right? That's what's important for us. And when we trigger CloudBuild, it's gonna do tasks that are defined in cloudbuild.yaml file. And I'm gonna show you what it's gonna do when it's doing it. But for now, that's the important part to understand. And later on, we're gonna go to that CD part as well. So let's trigger it. So what do we need to do to trigger it? Any ideas? So to trigger it, we need to do change to our test branch. So let's go to our test branch. I'm gonna do the change. So it doesn't matter to which file I'm gonna do the change, but I wanna do the change to my main.tf file. What I'm gonna do, I'm just gonna comment this one and comment this one. So what I'm doing, I'm trying to deploy Cloud Storage Bucket. Let me just change the name. I'm trying to deploy Cloud Storage Bucket in US West region, which if you followed me, then that region is not allowed for me to deploy Cloud Storage Bucket on. Yeah? I'm committing the change. Once I commit the change, my expectation is that my CloudBuild task is gonna be triggered and it's gonna keep on running. So in ideal scenario, it's taking 1 minute to run. And I'm hoping it's gonna be the same right now. So let me go back to our presentation. So what stage are we on? We're actually on this stage here. So we push the code to test branch that trigger our CloudBuild, and our CloudBuild is doing Terraform init, Terraform plan, Terraform vet, and vet part is verification part that is gonna verify if our Terraform plan is correct. Right, so this is where we are. So let's come back to our task that is running. It's still running for another, hopefully 1 minute, 30 seconds. And are there any questions on this part so far? Okay, I guess we're gonna sit in quiet and see if it's gonna succeed. In previous demo, it took me 5 minutes, but I know what was wrong, so I fixed it, and hopefully it should be done in 1 minute, 30 seconds. But we're not gonna maybe waste time. I'm just gonna show you what CloudBuild is doing. So basically, our CloudBuild YAML file is defining the steps that CloudBuild should be doing. And those steps are defined here, right? So our Terraform is doing Terraform init, Terraform plan, which is essentially saving our Terraform plan and saving in creating it. Then it's putting that file into JSON format, and then it's doing verification. And that's expected result. I know it's saying failed, but that's expected because the verification has failed. And how does it integrate with GitHub? Yeah. So on GitHub part, whenever my test branch is updated, what I want to do, I want to go. You want to have that second part checked before deploying. So you want to have someone go to GitHub and move your code from test branch to main branch. And once it's in the main branch, then it's deployed, right? So let's try to do it. Let's try to move our code from test branch to main branch. We're creating pull request, and we're gonna pull from our test branch to master branch. And we're gonna create pull request. And you can see that, okay, I can still pull that request in my case because I've got all the privileges. But what it's saying is that you can pull it, but the verification has failed, right? So if you pull it, then you're probably gonna mess up your environment because we did the checks and they failed, right? Because it failed on checking whether your cloud storage bucket is deployed in allowed locations, right? So it doesn't essentially allow me to pull my code to master branch, right? It's kind of warning me before I'm gonna do it. And we can actually even go from here to the link, copy the link, and open it. Doesn't work this way, but essentially it would bring me here to my CloudBuild task, and I can see that it was doing those checks and cloud storage bucket location and against this allowed location. And somewhere here, there should be a message saying that your cloud storage bucket is in disallowed location. Right? So now if I go to my GitHub, fix my location, let's go to test branch once again. We're gonna fix it. We're gonna put it into Europe. Let's put that. Just gonna change the name. And that triggers my check once again. It's gonna keep on running for another 1 minute and 30 seconds. But I wanted to go back to my GitHub and show you one more thing, because I mentioned about checks, but I have mentioned what do we check against. We check against policy library, and I can, after the session, I can share you the link. So there's a list of those policy libraries that we can check against. So currently there's around 60 checks that we can run it through, and you can build your own checks, right? Using those policy libraries. You can build your checks and check against many components that on Google Cloud that you want to check against. So that I know that it's gonna go through, right? Because I verified, but I just wanted to show you those CloudBuild files. So CloudBuild, I've got two CloudBuild files, CloudBuild YAML and CloudBuild YAML CD. So CD is doing the deployment part. So basically, this is the way you create those tasks for your CloudBuild, right? So you do terraform init, plan, then terraform plan to JSON file, and then you check against policy libraries, and those policy libraries are actually defined on my GitHub. And for simplicity, all the code here in my example is on one GitHub repository. But in ideal scenarios, you would want to, move those things around, right? So for example, your security team is keeping policy libraries, right? And is maintaining policy libraries, right? That's one of the potential scenarios, right? So you can depending on the privileges that you want to grant to each of the teams, you might structure it a little differently than that simple example that I showed. And let's go back just quickly to our task. And you can see it finished okay, so the checks were okay. And if I want to go back to my GitHub and I do pull request right now, you can see that all checks have passed, and I can merge and pull, confirm. So right now I'm pulling from my main branch, from my test branch to my main branch, and that triggers another CloudBuild that is doing the deployment. And I'm not gonna wait for that task to finish. I'm just gonna show you that it's running, and you can trust me that it's gonna be completed. And I think with that concludes my demo, second demo. And with that, thank you. Yeah, but I cannot just open for the questions if there are still any unanswered. But yeah, go ahead.
A silly question about that mistake. That last presentation, the cloud report took 5 minutes. What was that?
Yeah, that was